The moment everything changed. The room is silent. This is not the polite silence of a meeting. It is not the focused silence of scientists reviewing data. This is different. This is the silence of people who have just realized something and are not sure the world is ready to hear it. On the screen in front of them, a 14-second clip from a trail camera. Recorded deep inside Big Cypress National Preserve, Florida. Timestamp 2:47 a.m. What appears in the footage is not a ghost. It is not a glitch. It is real, it is alive, and it has shattered 2 decades of assumptions. Dr. Rian Bartosek leans forward. No one speaks, because what they are witnessing is not just an event, it is a signal. But before we watch that footage, before we understand how the swamp is beginning to destroy itself, we need to go back to the beginning, back to the moment when paradise became a killing field. And it all started with one decision that no one stopped in time. Paradise lost. The Everglades is not a swamp. That is the first mistake people make, and it is a costly one. It is a river. A slow-moving river, 60 miles wide and only a few inches deep, covering the entire southern tip of Florida. The Seminole people called it Paheoki, the grass water, for thousands of years. It was one of the most complex ecosystems on the planet. It filters drinking water for millions of people. It absorbs storm surges that would otherwise devastate coastal cities. It recharges groundwater. It stabilizes weather patterns across the entire southeast United States. Its ecological value, estimated in the tens of billions of dollars per year. Not because it is beautiful, though it is, but because of what it quietly does. Life thrives everywhere in this system. Flocks of wading birds move across the sawgrass prairies. Alligators rule the sloughs. Deer forage in the cypress domes at dusk. Raccoons, opossums, marsh rabbits, foxes, bobcats, a food web built over millennia, layer upon layer, each species dependent on the others. Then came August 24, 1992. Category 5, Hurricane Andrew slammed into South Florida with sustained winds over 165 miles per hour. At the time, it was the most destructive hurricane ever to make landfall in the United States. It flattened neighborhoods, tore apart buildings, and erased entire communities in hours. And near the town of Homestead, it destroyed a reptile breeding facility. When the storm passed, Burmese pythons escaped into the wetlands. Witness former facility employee. No one wanted to believe it was that bad. We were just trying to figure out what was left. Snakes were the last thing on anyone's mind. But Hurricane Andrew was not the whole story. It may not even be the most important part. Throughout the 1990s, Burmese pythons became a popular exotic pet. They were cheap, they were impressive. As hatchlings, they were small enough to fit in the palm of your hand. Sleek, beautifully patterned creatures that looked like they belonged in a museum. What people didn't consider. Hatchlings don't stay. Hatchlings, a tiny snake that fits in your palm, becomes within 3 years a 10-foot-long, 50-pound ambush predator. It needs live prey. It needs space the size of a room. Feeding it would cost hundreds of dollars a month, and when owners realized what they had gotten into, many made a decision that felt like mercy. They drove to the edge of the Everglades. They opened the car door. They set the snake down in the grass and told themselves they were giving it a better life. They were not. They were unleashing a biological invasion. The ghost predator. Burmese pythons move without sound. In the Everglades, that is not a metaphor. It is literal. A Burmese python hidden in thick sawgrass is nearly invisible. Its brown, gold, and black pattern perfectly matches the dead vegetation. It doesn't need to chase, it doesn't need to pursue, it only needs to wait. And what makes it so devastating is this. Everything it hunts evolved in a world that had never known anything like it. A Florida raccoon had spent thousands of years learning to fear hawks, alligators, and bobcats. Its instincts were tuned to those threats. It had no alarm response for a 10-foot snake lying motionless in the water for 6 hours, waiting for the perfect moment. The python detects the raccoon-esque body heat through heat-sensing pits along its jaw. Total darkness. Absolute silence. The raccoon doesn't know the snake is there until the coils wrap around its rib cage. Then it ends in seconds. A female python can lay up to 100 eggs in a single clutch. With no natural predators to control their numbers. Nothing in Florida evolved to hunt a large, patient, cold-tolerant creature like this. Their population exploded, slowly at first, then all at once. When the final data came in, the numbers were staggering. In the hardest-hit areas of the Everglades, raccoon populations had plummeted by more than 99%, not declined. Not reduced, nearly wiped out. Opossums, nearly the same. Bobcats, collapsed. Marsh rabbits and foxes, virtually gone from survey areas where they were once common. Biologists who had spent 30 years studying this ecosystem described driving the roads at night roads where animals used to constantly dart through the headlights and seeing nothing. Miles of habitat, complete silence. The swamp still had life, but something essential had been eaten away. Field researcher, reviewing data. You walk a transect where you used to record 20 species, and now there's one, maybe two, and it's not because you did anything differently, it's just the animals aren't there anymore. Not diminished, erased, and the invasion was still accelerating. Hunting ghosts. Florida's response, when it finally came, looked from the outside like a sporting event. The Python Challenge, an open competition. Registered hunters would head into the swamp to catch as many invasive snakes as possible. Cash prizes, annual sensational headlines, the feeling that something was being done. The math told a different story. In 2024, the total number of pythons removed during the Python Challenge was 195. From a population that may number 300,000. Removing 195 snakes out of 300,000 makes no meaningful difference. It is barely visible. It is like trying to drain a lake with a teaspoon while the lake is refilling faster than you can scoop. Since 2017, professional hunters have removed more than 23,000 pythons in South Florida. That sounds enormous until you do the math. In the best-case scenario, it represents less than 10% of the estimated population. In the worst case, far less. The problem is not commitment. The hunters are real, the funding is real, the effort is serious. The problem is the animal. Infrared drones designed to detect heat signatures struggle because pythons are cold-blooded. In the heat of the Everglades, a motionless python on warm ground barely registers. The snake disappears from thermal imaging, the same way it disappears from human sight. Mechanical lures failed. Burmese pythons are ambush predators. They do not chase, they wait. A fake animal moving on a wire elicits no response. The Judas snake program, tagging pythons to lead researchers to breeding concentrations, had limited success. But limited success was not enough to collapse the population, not even close. Then field teams began noticing something far more alarming. The pythons were changing. Traps that worked in one season stopped working in the next. Productive hunting corridors fell silent not because the snakes were gone, but because they had moved. Deeper into the terrain. Farther from roads, from access points, from areas where humans could realistically monitor them. Dr. Ian Bartosek's team at the Conservancy of Southwest Florida documented shifts in python movement patterns across seasons. The snakes were increasingly avoiding human activity corridors, not randomly. Not occasionally, but systematically. There are two explanations. Both are terrifying. First, individual snakes are learning. They detect human activity and move away. Behavioral adaptation happening in real time. Second, natural selection has taken place. The careless snakes, the ones that crossed roads and stayed in accessible areas, were the ones caught and removed. The cautious ones survived. The cautious ones bred. Their offspring were born cautious. Either way, the result is the same. An already nearly undetectable apex predator has become even better at evading detection. Florida threw everything at this invasion. Hunters, drones, traps, biological lures, professional tracking teams. The invasion adapted, and then came a threat no one saw coming. A threat that had been everywhere before anyone knew to look for it. The invisible killer. While researchers focused on the pythons, something else was spreading across Florida. Silently, invisibly, moving through water, soil, and animal carcasses in a chain no one had mapped until it was too late to stop. Scientific name, Ralliachella orientalis. Scientists call it the snake lungworm. Dr. Christina Romagosa, a wildlife scientist at the University of Florida, first encountered it while studying native Florida snakes for a different project. What she found stopped her cold. Striped snakes, pygmy rattlesnakes, common, healthy species. Animals that should have looked healthy, they did not. They were emaciated, sluggish, struggling to breathe. When she opened them up, she found the cause. Their lungs were full of worms, tiny pale parasites, dozens of them burrowed into lung tissue, blocking airways, feeding on blood, and spreading throughout the body. Species that had never evolved to carry them, never developed resistance, never had a chance. Dr. Romagosa, field interview. We were dissecting animals that looked like they might recover and found their lungs were catastrophically damaged. This doesn't happen slowly. It is severe, immediately severe. Once mapped, the transmission chain is astonishingly elegant. An infected python sheds waste into the swamp. Cockroaches eat it. Inside the cockroach, the parasite larvae develop. A frog eats the cockroach. A native snake eats the frog. And inside the native snake, the larvae do not stay in the stomach. They tunnel through the stomach wall, they migrate to the lungs, they attach, they feed, they multiply. As the infection progresses, the animal stops eating. Breathing becomes labored. Movement slows. Eventually, it suffocates. In the worst cases researchers recorded, the worms crawled out of the mouths of still living infected snakes. That alone was alarming enough. Then came the more horrifying discovery. The parasite had spread beyond the Everglades. At least 18 native snake species were found infected. Cases had been recorded as far north as Jacksonville, far beyond the historical range of the pythons. Far beyond any area researchers had been searching, and most importantly, it no longer seemed to need Burmese pythons to survive. It had spread. It was now transmitting from snake to snake, sustaining itself within native populations, a self-perpetuating cycle. That means, even if every python in Florida were removed tonight completely, permanently the parasite would remain. It had embedded itself. It had taken root. The invasion had planted a biological time bomb that would continue detonating long after the snakes themselves were gone. The Everglades was now being attacked on two fronts at once. From above, pythons devouring mammals. From within, lungworms devastating the reptile populations that form critical links in the food chain. Two battlefronts, one ecosystem, and the window to stop either was closing fast. But Romagosa's team found one glaring anomaly. There was one species in the infected areas that consistently came back clean. The Florida cottonmouth, a venomous snake living in the same habitats. Drinking the same water, eating the same prey, showed no signs of lungworm infection. This held across multiple surveys, and years no worms, no respiratory distress, nothing. Something in the cottonmouth's biology was stopping the parasite. No one yet knows exactly what blood chemistry, immune response, venom components, all are hypotheses, none confirmed. But the implications are enormous. If one native snake species has cracked the code of resistance, that resistance could potentially be transferred. It is a key to protecting other species, a starting point for something that might actually work. Scientists have called this one of the most urgent unanswered questions in Florida wildlife biology. And while they were still researching that, Florida announced a plan that sounded completely insane to most people. They planned to release more snakes, the return of the king. When the announcement was made, the reaction was immediate and fierce. More snakes, into an ecosystem already devastated by snakes. Comparisons to the cane toad in Australia spread instantly, the classic example of human solutions becoming far worse disasters than the original problem. But this time was different. The snake being released was not an invader. It was a native predator returning to the kingdom it had lost. The eastern indigo snake Drymarchon cooperi, the longest native snake in North America. A sleek, glossy blue-black animal that can reach 8.8 feet, 2.7 meters, built not for patience but for speed and aggression. A fast-moving predator that seizes prey with powerful jaws and swallows it alive. The indigo is immune to the venom of North American pit vipers, rattlesnakes, cottonmouths, copperheads. It eats them without issue. For thousands of years, nothing on the ground could stop it. It did not disappear because another predator beat it. It disappeared because humans destroyed its shelter. Eastern indigo snakes depend on gopher tortoise burrows. These underground tunnels dug by tortoises that can live 80 years or more provide the temperature regulation, humidity, and protection the indigos need to survive Florida's climate swings. As urban development destroyed longleaf pine forests and scrub habitats, gopher tortoise numbers declined, and wherever the gopher tortoises went, the indigos followed by 1978. Eastern indigo snakes had nearly vanished from northern Florida, a native apex predator gone from its own territory. For decades, a coalition of conservation groups worked quietly on a seemingly impossible mission. They bred indigos in captivity. They restored longleaf pine forests. They reintroduced gopher tortoises into protected habitats. Step by step, they rebuilt the ecological infrastructure the indigos needed to survive if they ever returned. Then in late 2023, a trail camera at the Apalachicola Bluffs and Ravines Preserve captured something extraordinary. Two young eastern indigo snakes, tiny, moving through leaf litter. Born in the wild, these were the first wild-born eastern indigos documented in northern Florida in roughly 50 years. Dr. Kevin Enge, a herpetologist with the Florida Fish and Wildlife Conservation Commission, was part of the team that reviewed the footage. Dr. Enge, you spend years on a project like this, and you prepare yourself for the possibility that it might not work. But when you see those two animals born in the wild, healthy, moving on their own, it did something you never forget. The king was not just surviving, it was reproducing. For the first time in half a century, eastern indigos were rebuilding a wild population in Florida without direct human intervention. The return was no longer a plan. It had begun the native counteroffensive. For 20 years, the story of the Everglades had only gone in one direction. Pythons were the predators. Native wildlife was the prey. The invasion spread. Mammals vanished. The food web collapsed. That was the story, and nothing could interrupt it. Then Bartaseka's team picked up a signal from a Burmese python they had named Loki. Loki weighed about 50 pounds, 22.7 kilograms, a large mature snake. The research team had been tracking him for weeks across Big Cyprus when the signal stopped moving and stayed in one place. They went in. They did not find a living snake, they found a carcass. Loki's head had been bitten off. A nearby trail camera had recorded the event hours earlier. The footage clearly showed the attacker, a bobcat. A 25-pound Florida bobcat, roughly half the weight of the snake, had stalked, positioned, attacked, and killed a 50-pound Burmese python when Bartasek watched the footage. Those in the room said he went completely silent. Then he asked for every nearby camera to be checked immediately, because this was not a singular freak event. Reports were coming in from across South Florida, native predators interacting with pythons in ways never recorded during the first 2 decades of the invasion. Alligators ambushing smaller snakes near the water's edge. A Florida panther caught on camera taking down a medium-sized python in the sawgrass. Native predators identifying specific moments when pythons were vulnerable after a large meal. While crossing water, during the brief transition from ambush to movement, it turned out ambush predators could themselves be ambushed. This does not mean the pythons are losing. They are not. Their numbers still overwhelmingly favor them. One bobcat cannot reverse 20 years of decline. One panther clip cannot rebuild the food web. But the dynamic had shifted. It was no longer a one-sided slaughter with no resistance. For the first time, it looked like a fight, and wars, unlike invasions, do not always end the way they begin. Collision course. Now hold everything you have just learned. Keep it in mind as we look at what is coming. The eastern indigo snake population is expanding. Wild-born snakes are beginning to move out of the restored habitats in northern Florida. The reintroduction program is producing real sustainable results for the first time. At the same time, Burmese pythons are moving north, along waterways, along warming temperatures, along connecting habitat corridors, pushing deeper into Florida than ever recorded. 2 expanding fronts, both moving toward each other. No one knows exactly when they will meet. The timeline depends on climate, habitat, water levels, and food availability. But the math is clear. Eventually they will collide. An eastern indigo, fast, aggressive, immune to pit viper venom. Evolved to hunt and kill other snakes, facing a Burmese python that may outweigh it by 40 pounds or 60 or 80. The indigo strategy has never been size, it has always been speed. Powerful bite force, aggression, and absolute refusal to let go. It has killed rattlesnakes, it has killed cottonmouths, it has overpowered animals that could have killed it with one bite. But it has never faced an adult Burmese python. No one has recorded that encounter. No one knows the outcome, and layered on top of that collision is the parasite. The lungworm is also moving north. Documented in 18 native species, self-sustaining, no longer dependent on pythons for transmission. If eastern indigos expand into infected territory before scientists understand whether they have resistance, before the cottonmouth's immune system is decoded, before any protective measures can be developed, they could walk straight into a biological trap, a species that took 50 years to recover, a population only now beginning to stabilize, potentially facing a microscopic parasite that destroys lung tissue and against which they have no defense. 50 years of conservation effort, thousands of hours of captive breeding, habitat restoration across hundreds of acres, the first wild-born gopher tortoises in generations, all of it potentially colliding with a worm no one yet knows how to stop. And there is one more variable. The bobcats are learning. The footage of a 9.3 kilograms bobcat killing a 23 kilograms python is not just a remarkable moment, it is evidence of behavioral transmission. Young bobcats watch adults. They learn effective hunting techniques. If killing pythons becomes a learned behavior passed through the population, the generational consequences could be significant. The same may be true for panthers, for alligators in specific conditions, for any native predator that discovers, survives, and passes on knowledge of how to take down an invasive snake. Evolution does not operate on a timeline that matches human patience. It operates across generations, and it is already happening. Part 8. The meaning of the footage. So now we return to that room, that silence, those 14 seconds of a trail camera footage. What Bartasek's team witnessed was not just a bobcat killing a python. It was the first documented evidence that the native wildlife of the Everglades has begun naturally, without human intervention, to develop responses to the python invasion. Not at a scale large enough to repair 20 years of damage, not at a speed fast enough to rebuild the collapsed food web, but real, measurable, documented. After 2 decades of passive decline, the swamp had begun to fight back. That is why the room fell silent, not because of victory, not because of relief, but because of something more complex and more unsettling than either. They realized what they were seeing was no longer simply an overwhelming invasion of a fragile ecosystem. It was the beginning of something new, something that does not yet have a name in the scientific literature. An ecosystem in the midst of violent restructuring, fighting with every biological tool it has left, improvising solutions no one anticipated, answering questions no one had thought to ask. A devastated wilderness beginning to fight for its own survival. Cottonmouths resisting a parasite their immune systems had never encountered before. Why? A bobcat half the size of its prey learning angles, learning timing. How? 50 years of recovery effort producing wild indigos that are now slowly, inexorably moving toward the range of the most successful invasive reptile in American history. When they meet, what will happen? Conclusion: the unanswerable question. No one knows. That is not understatement. It is not scientific caution. That is the current state of knowledge in 2025 in one of the most studied ecosystems in North America. The indigo may arrive in time. It may take hold before the lungworm reaches its range. It may be resilient enough. It may win confrontations no one can yet predict. Or the parasite may arrive first. 50 years of conservation colliding with a microscopic worm moving through the water chain, and the recovery collapses before it can fully take root. Or the bobcats may learn faster than anyone imagined, or they may not. Or the panther footage may be an exception, not a trend, or the beginning of something. Or the cottonmouth's immune system may unlock a treatment, or the research may take another decade. Every variable is real. Every outcome is possible. The true ending remains completely open. And that after 20 years of a story that seemed to have only one direction is extraordinary. The Everglades is still wounded. The invasion is not over. The parasite is still spreading. The mammals have not returned. The silence in some areas of the swamp remains, still palpable, still devastating, but the ecosystem has begun to move again, and that movement, after 20 years of collapse, is the most important thing that has happened in this story since the hurricane destroyed a breeding facility in 1992 and released the first snakes into the grass. The bobcats are learning. The king is breeding. The cottonmouth carries a clue no one has yet decoded, and the swamp is no longer still. Who will win this war? The invader that has dominated for 20 years? The parasite that no longer needs its original host? The native predators returning after a half-century absence? Or the ecosystem itself adapting, improvising, fighting with biology? Time and selective pressure in ways no hunter, no drone, and no government program can replicate? Leave your prediction in the comments, because the swamp still has more to show us, and this story is far from over.